All right, so I want to solve this. One problem I have is they're different periods. So that's a little bit of a complication. Usually, a lot of times when we're solving equations, we try to get 0 on one side. That worked a lot in the last section. So I could rewrite this as the cosine of 5x plus the cosine of 2x equals 0. Now, what would help next if I could turn that right there into a product? Oops, product again here. Then I can split the product and solve. So it turns out if you play with those sum and difference formulas some more, you can turn a sum into a product. So I'm not going to go over all the details of how that happens. I'm just going to look up the formula. There's a ton of formulas in, am I in the right section? Oh, that's 7.1, not 7.2. All right, so let's see. No. Just did one like that. Those are for the same period. Same period. There we go. Product to sum, and then it's stated separately. Yeah, the sum to product identities. All right, so we are starting off with a pair of cosines, and they're being added. So that means we should be able to apply this formula right here. I'm going to steal that into my notes. All right, so here's the formula that I should be able to apply. So what it says is you just average the inside of the cosines, and then you find half the distance between them here. All right, we can do that. So I'm going to get a 2 on the outside. And then I'm going to get a cosine of 2x plus 5x, so 7x over 2, times a cosine of the difference, so 5x minus 2x, or 3x over 2. Well, this is equal to 0, so now I can split it into two different problems. So one problem is going to be twice the cosine of 7x over 2 equals 0. And the other is just cosine of 3x over 2 equals 0. The 2 on the first one conveniently divides away. So I just need to know when the cosine of 7x over 2 is equal to 0. All right, let's think about that unit circle-wise. Cosine is an x value equals 0 at the top and the bottom. So what angles do I want? That angle right there would just be pi over 2. And this angle right here would be 3 pi over 2. Okay, so that gives me colors 7x over 2 equals pi over 2. Multiplying both sides by the reciprocal, 2 over 7. Then I get one solution should be x equals pi over 7. And similarly with the 3 pi over 2, I'm just going to multiply that by 2/7. So the other one, the 2's will divide out. That looks like 3 pi over 7. And we'll check these on the graph in a moment. Similar for the other one, that's similar. When is the cosine equal to 0? That's a 2 there. Well, it's at the same 2 points with the angles pi over 2 and 3 pi over 2. So over here, I'm going to get 3x over 2 equals pi over 2. So then x is going to be pi over 2 times 2 over 3, which is pi over 3. And the other one would be 3 pi over 2 times 2 over 3. And lots of stuff cancels there, leaving just a pi. So those should be my other two solutions. Now, the difference between this and the previous problem we worked on here, we had two different periods, and we did not have multiples of the sine and the cosine floating around. If they're different multiples, that's a problem. I got to come up with a different way to solve it. The previous problem, we had the same inside, but we had different multiples outside, so that was a different technique. Does this mean there's techniques to solve any trig equation? The answer is no, but we can solve a heck of a lot if we pick the right identity. Now, again, there are tons of identities in this section. I don't expect to memorize all of them, but there's a few I'll point out that these are good ones to know. This one right here, I don't have memorized. I look it up when I need it.